In Algebra 1, Section 3.1, we're dealing with solving systems of equations. Now, systems of equations are basically two equations with the same, with an overlapping point that they share. And so two lines, when you cross them together, the point where they intersect, that's a solution to the system of equations. So they share a point in common. Sometimes they overlap entirely, so they share all points, and sometimes they're parallel, so there's no points. That would be no solution. So the whole goal here is to find that one point that these two equations share. So I'm going to take each one and I'm going to graph each line independently. And so it's nothing really new with this whole the whole graphing. It's just I'm going to graph two lines in one graph so that I can see where they intersect. So my first one is x minus 2y equals 0. So I'm going to solve for, I'm going to put it in the y equals mx plus b form so that I can graph the way I need to graph. So y equals mx plus b, we're going to subtract x from both sides. And we're going to do, this cancels out. And I end up with 2y equals negative x plus 0. And then we're going to divide by negative 2. These cancel out. So I end up with y equals, I'm going to give this negative 2 to each one. So this is negative 1 over negative 2x plus 0 over negative 2, which is the same thing as saying y equals 1/2 x plus, and 0 over anything is 0. So here's my equation. And when we're graphing equations of a line, you can also do a table if you want, but this is our starting point. This is my my b, my y-intercept. So here's my x. And here's my y. So this is my y-intercept. So 0. Where is it? So I start at 0 here, right? And then this is my movement. So starting point, and this is how I move. So I'm going to go, it tells me to go, this is how many I go up and down, rise over run. So I'm going to go up 1, starting at 0, I'm going to go up 1 over 2. Up 1 over 2. And this is my line. This might be helpful if you do a graph paper, because you need to be a little bit more exact than other graphs, because we're looking for exact points that overlap. My next one is x plus y equals 6. So I'm going to just subtract x from both sides. I end up with y equals negative x plus 6, right? So this right here is a negative 1. And in order for me to make it a fraction, because if I have the movement, I need a fraction, I'm going to put it over 1. Any whole number can be made in a fraction by putting over 1. So this is my starting point. I'm going to start at 6. 1, 2, 3, 4, 5, 6. And now I'm going to move down 1 and positive 1. Down 1, positive 1. Yes, down 1, positive 1. Down 1, positive 1. Down 1, positive 1. And this is where they overlap. So this is my overlapping point. 1, 2, 3, 4, up, 1, 2, up 2. So 4, comma 2. Hopefully that's right. Actually, my graph is not exact, so it's a little harder to tell. But what this means is if I plug this in, my x and y, to here, it should prove this equation true. My x and y here, it should prove this equation true as well. So it works for both. I need you to see this just to be able to graph, but you're not going to be doing too much on the assignments. There's algebraic ways to solve this to make it easier so you don't have to graph every time. But you need to understand that the solution is basically this one point that both equations overlap. So go ahead and write this down. And I'm going to go over the two algebraic methods on how to solve for the system of equations without having to graph. The first method is called substitution. Now, substitution is the easier one from elimination, only if you have a variable that doesn't have a number in front of it. So the other one we're using is elimination. Okay? Elimination works for anything. So if you want to just learn one method, master elimination, because it applies for everything. But it is a little bit longer than substitution. So if you can learn both, that's great. But if anything, just master elimination, you should be fine on the test or in anything that has to do with systems of equations. But systems is shortcut, but it only works if you have one variable, because we have 4 variables to choose from, right? If I have one variable that only has a 1 in front of it, okay? In this case, we have 3, so we're good. In this case, all these variables have a number in front of it besides 1, so we wouldn't be able, it wouldn't be smart to use substitution. It's not that the method is impossible to use it, it would just be a lot more work than it would be worth. So for substitution, I'm going to solve one of the equations for x, or a variable. So I'm going to take this first equation right here. So x plus 2y equals 10. So I'm going to solve for an equation. Solve for the variable that's by itself. So that means I'm going to get rid of the 2y. I'm not trying to separate the 2 and the y, so I'm not dividing. I'm taking the whole thing and moving it over. So the opposite of positive 2y would be negative 2y. Negative 2y on each side. So I would end up with x, because this cancels out, equals 10 minus 2y. Right? So my first step is to solve for a variable. Okay. My next step is to then replace that variable. So I'm going to move it here. Replace to other equation. So what I'm going to do is this equals x right here, right? So that means that this bubble represents x in both equations. So I'm going to take this and I'm going to bubble it and I'm going to replace it for all that is x. So watch what I'm doing here. I copy this entire equation right there. But instead of x, because now I know that x, okay, equals this, I'm going to erase x and I'm going to put this whole bubble in here. Why am I doing that? Well, I can only solve equations if there's one variable in there. And the reason why I couldn't solve these is because there's 2 variables. But by finding what x means in terms of y and replacing it, now I have an equation with only 1 variable, and now I can solve. So I end up with 10, and then negative 2y plus y gives me negative y equals 6. I'm going to subtract 10 from both sides. I end up with negative y equals negative 4. Divide by negative 1. This cancels out. I end up with y equals 4. Now that I have y equals 4, my last step is to solve for the final variable. And I can do that. If this 4 is for either one of these. So I can choose whichever equation I want to use. And the second one seems a little easier, so I'm going to put it in for the second one. So x plus y equals 6. I know that y equals 4, so x plus 4 equals 6. And then I'm going to subtract 4 from both sides. I end up with x equals 2. Okay? So my answer here is not these two, but it's x comma y. So 2 comma 4. Right? So that means if I plug in 2 comma 4 for my x and my y, I should they should solve true. So if I put 2 in for here and 4 in for here, so that's 4, 8 plus 2 is 10, done. 2 in for x, 4 in, 2 plus 4 equals 6, done. So that's what this equals, I mean, this is what this is. And if I graph these two, they would intersect at 2, 4. Okay? So our next one is called elimination. And I'm doing something similar. I'm going to go ahead and mark this to be on this side right here. Okay? So my goal is a similar thing. I'm trying to get it so I only have one variable. But in this case, I'm going to manipulate entire equations to get rid of the variable. For example, look at 2 and negative 5, right? A common multiple that they have is 10. So what I want to do is I want to change this into 10. Well, in order for me to change this into 10, I have to multiply this by 5. And I can do that. I can do anything I want. The key is I have to keep the equation balanced. So if I want to multiply this by 5, I have to multiply every single term by 5. And remember, terms are separated by addition, subtraction, and the equal sign. So I have to multiply each of these and then every term. So I'm going to take this and I'm going to multiply it by 5, which gives me, right, I'm going to distribute it, 10x plus 20y equals, why can't I, 60. Okay? Now, my goal is to get rid of the x, so I have to cancel it out. So the opposite of 10 is negative 10. So since this is already a negative, I just have to multiply this by a 2. And again, if I want to do that, I can. I just have to multiply every term by 2. So then I end up with 2 times negative 5, which is negative 10x, and then 2 times negative 10, which is negative 20y, and then 2 times negative 30, which is 2 times negative 30 equals negative 60. All right? So basically what happens is then I'm going to subtract it. I'm going to do 10 minus 10x minus 20y. So if I subtract all of these, they actually all equal 0. When I end up with 0 equals 0, this means that they're the same lines. Remember, so if they're the equals on both sides, this is all solutions. If they're not equal on both sides, then I have no solutions. This is actually kind of a bad example on elimination because it doesn't bring you through everything. So I want you to go ahead and pause and write this down. But I'm going to solve this one right here with elimination. So my equation is x plus 2y equals 10 and x plus y equals 6. So I'm going to solve this with elimination so you can see the full equation because this kind of just stopped us because they ended up canceling. 10 minus 10 equals 0, right? 20 minus 20 equals 0. 60 minus 60 is 0, so I end up with 0 equals 0, which means it's all solution. But I want you to see elimination in its length full. So go ahead and write this down, and we're going to solve this one, the substitution one, and we should be ending up with 2, 4, right? So it's the same method, right? I'm trying to make these, I'm trying to eliminate a variable. The lucky thing for us is that I don't have to do the multiplication thing because I already have 2 variables that are the same. Now, I want to make one variable opposite. So if this variable is x plus 2y equals 10, and this one is x, I want to make 1 into a negative. So I'm going to put this into a negative 1. So this will then be, negative x, okay, then minus y equals negative 6. And I'm just going to bring this one over. Once I bring it over, then I'm going to add them. Okay? When I add them, positive x and negative x cancel out, right? And I do positive 2 minus, this minus is with a negative. Positive 2 plus a negative y, so it's positive 2 plus 1, so I end up with just 1y, and then 10 plus negative 6, which gives me 4, right? So I end up, and then I have to solve this, which it's already solved, but if, for example, if this was a number, I'd have to divide it and solve for y, but I have y equals 4. Then, once I eliminate 1, then I can plug it into whichever one. It doesn't matter which one. I'm going to plug it in to the first one. X plus 2 times 4 equals 10. Right? So my first step is to eliminate a variable. My second step is to solve for a variable. And then my third step is to plug in and solve for the last variable. Okay? So that means I'm going to take this, I'm going to take the first one, because the other one I did the second equation, so I'm going to do the second equation. So it's x plus 2 times 4 equals 10. X plus 8 equals 10. I'm going to subtract 8 from both sides. I end up with x equals 2. So here's my answer. I end up with 2, 4, which is the same answer I got when I did for substitution. Right? Different methods, but you see how this method, it doesn't matter what's in front, just like I did, for example, number 3 on this board right here. Everything had it, and I just multiplied it by whatever I wanted. I just had to make sure to multiply it by each term. This one too. So elimination can be used for any of the systems of equations that you're using. So this would be an important one to master. So master this one first. Substitution is just a shortcut in case you have variables without a letter in front of them. So go ahead and write this down. Pause it and write it down. And I have you down for page 141, number 17, 22, and 23. Page 141, number 17, 22, and 23. And I will see you in class.